I'm Edwin Ellis. I'm a professor in the College of Education at the University of Alabama, and I'm also an affiliate research scientist at the University of Kansas Center for Research on Learning. And this is part 3 of a series of videos about using visual tools for teaching the Common Core standards. Now, back in part 1, I provided an overview of the role of using visual tools and how they can be useful when you're teaching the more complex standards, particularly visual tools that are discipline specific. In part 2, we took a look at some of the software instructional resources, and also we discussed a little bit about the importance of the instructional routines that accompany the visual tools. And it's not just about the visual devices, but also about how they're used. In this presentation, we're going to take a look at the overview of the research basis for the Genius model. If you haven't had a chance, you can download this presentation from graphicorganizers.com, so if you want your own PowerPoint version of this, you can access it there. So the question before us is, how well do these visual tools work? Now, in earlier presentations, I've mentioned that there's an extensive research basis that basically validates the use of visual tools for doing a wide range of things like improving reading comprehension, teaching vocabulary, increasing writing skills, facilitating content area learning like learning math, science, and history, and so forth. And they really work across the board in terms of high achieving, typical achieving, low achieving, and students with learning disabilities. The problem is the more generic tools like webs and Venn diagrams and so forth, their effectiveness really falls off dramatically as these Common Core standards get increasingly more complex. They really just don't get the job done. And so what you need are discipline-specific visual tools. Now, these are tools specifically designed for teaching history, which are different from those that are specifically designed for teaching science and literature and so forth. And they're also designed for teaching very specific, complex Common Core standards. So we're going to take a look at some of the research basis for those discipline-specific visual tools. I'm not going to be providing all of the research here, but rather just giving you an overview to give you a sense of what is the research basis and the nature of the research that's been conducted. Basically, we've conducted a series of large N quantitative studies that employ both true and quasi-experimental research designs. We've conducted some qualitative studies as well as some program evaluations. Typical measures include things like general performance on high-stakes tests, performance in specific skills like writing, knowledge of vocabulary, and so forth, depth, breadth, and accuracy of new content knowledge. In other words, how much new science do students understand when these tools are used, or how much new knowledge of history, etc. We've also looked at the social validity, which are basically how much do teachers and students really value these tools. And we've also examined fidelity and factors that affect it. In other words, when teachers are attempting to use this in the day-to-day classroom environment, what are the various factors that affect their ability to use these effectively? And so I'm going to provide an overview of a few sample studies. We're certainly not going to address all of them, but the intent is just to kind of give you a sense of the nature of the research. This study took a look at the effectiveness of discipline-specific visual tools that were designed specifically for teaching history. And this study, it was a large N study, so we had 32 high-achieving, 32 typical achieving, 32 low-achieving, and also 16 students that were considered low-achieving but also had been identified as learning disabled. And so we were interested in looking at what were the effects of using these visual tools versus traditional kinds of instruction teachers use. So in this study, we had a couple of teachers, so I'll call it Teacher A and Teacher B. And Teacher A, during the first week, taught a mini unit using traditional guided note-taking discussion kinds of instruction you typically see in a history class. And so at the beginning of the week, we measured how much knowledge of the topic of the mini unit students already knew. And then at the end of the week, we measured again to see how much new knowledge they gained as a function of the kind of instruction that was used during that week or during that mini unit. At the very same time this was going on, Teacher B was actually using the American History Genius visual tools, teaching the exact same information as in Teacher A. And so in this study, we basically used the teachers, and they served as control groups for each other. So for an example, in week 2, Teacher A then switched and used the American History Genius tools, whereas teacher B switched and used the traditional guided note-taking discussion kinds of instruction. And so these teachers sort of served as their own control groups by using this reversal design. So again, we're looking at changes in how much knowledge of history were gained as a function of the instruction that was being used. And so first we measured how much new knowledge of history that high-achieving students typically gain when traditional content instruction is used. And so basically that allows us to sort of create a high water line in terms of what's the best we could expect to happen in terms of a typical classroom. In terms of what's expected in a typical classroom when traditional instruction is used. And then we measured how much typical achievers learn in that same classroom at the same time during the same kind of instruction. And not surprisingly, there's a gap between how much typical learners learn versus how much the high achievers learn. And that gap is basically the high achievers are learning about 21% more than the typical achievers. Likewise, we did the same thing with students that are considered low achieving to look at what that gap is, as well as students with learning disabilities. And so now we get a sense of how much learning occurs when traditional instruction is used across these different types of students. Then we looked at what were the differences when the teachers used the Genius history visual tools and what happened relative to the traditional instruction. And so basically what we found is that when teachers were using the Genius tools, the typical learners learned within 4% of what the high achievers were learning when traditional instruction was used. So there's a big gain there with Genius. Likewise with low achieving students, within 9% of what the typical achievers learned during traditional instruction. Students with learning disabilities, slightly less, but still significantly more. So at first glance, it kind of seems like Genius is a really powerful tool for reducing the achievement gap. The reality of it is we really didn't find that, because what we found is that all students were significantly enhancing their knowledge when teachers were using the Genius materials. And this is kind of unusual because typically intervention studies like this will find significant changes in students with LD, low achievers, and typical achievers, and you'll find a lot of gains there. But the high-achieving students typically don't change that much. This study was a little bit different in that we found that not only did Genius affect the high achievers, it actually significantly improved theirs, really more than the others. So this is kind of a rare finding where it's one of those things that seems to work really well across the board. So at first glance, it looks like we are reducing the achievement gap. But the reality of it is we're just kind of raising the bar. That while all students were significantly increasing their knowledge of history, the gaps remain, and if anything, they get a little bit worse or wider than they were before. But I'll go with raising the bar. I'm happy with that. This is another study. Now this looked at vocabulary learning in an 11th grade history class. And in this study we looked at how much vocabulary students that were typical achievers are typically demonstrating their knowledge of on quizzes that focus on questions related to their knowledge of vocabulary. And not surprisingly, they're learning about 81% of the vocabulary. Kids with learning disabilities, 11th graders, not quite so well. Low C level, like 71%, so about 10% less than typical achievers. Then we started using Genius with both groups. This was an inclusion classroom, so they're all together. And what we found with the typical achieving 11th graders, what happened to their knowledge of vocabulary when Genius used is it went from a low B, like 81%, to a high A, or 98%. So we're sort of clicking our heels at that. That looks pretty good. Then we wanted to see, well, what happened to the students with learning disabilities? And basically we found that they went to high A's as well. So this was pretty encouraging. Very significant gains, and particularly powerful for the students with learning disabilities. Speaking of which, this is a study that looked at 8th grade students with LD and looking at writing fluency. Now, writing fluency concerns how much language is actually being produced when you're writing. It's not looking at things like organization of writing or how persuasive an argument you're making and things like that. This is strictly looking at fluency. This was a true experimental design. And so what we did is we randomly divided students with learning disabilities into a control group and an intervention group. And so there were 28 students with LD in the control group and 28 in the experimental group. And we also had a group of 20 typical achieving 8th graders. Now what we were looking at is performance on a simulated high-stakes writing assessment type of task. And so in terms of writing fluency, we were looking at, well, how well does a typical 8th grader do on a task like this? And so what we found was, on average, a typical 8th grader will write about 117 words on high-stakes essays, where students with LD predictably do a lot less. And so for an example, overall, 8th grade students with LD in this study were typically producing around 27 words as opposed to 117 on the same task. And so you can see that the control group is roughly the same as the experimental group as their performance. They were not significantly different. And as you might guess, on the post-test with the control group, since we really weren't doing anything different, we really didn't get much in the way of changes. In fact, they regressed a little bit, but that's really not a significant amount. However, the students with LD that got the Genius instruction went from an average of 29 words up to 126 words. Now, what's really interesting about this is if you look at the typical achievers, 117 words, the kids with LD were actually outperforming the typical achieving kids when Genius was used. This is a study that looked at a series of program evaluations. And so this study didn't use a control group per se, so it wasn't experimental design per se, but rather a different kind of research that just looks at overall effects of a program. In this study, what we examined was 26 different schools, and they were divided into groups. And so we had 9 schools that were sort of red flag schools that were doing extremely poorly on the annual high stakes writing assessment. And so only around 21% of the students in those schools were actually meeting the standard. We also looked at 8 schools that would be considered low performing, and so close to 39–40% of those students were meeting the standard. And then we had 7 schools that were moderately performing, so nearly 60% of those students were meeting the standard. And then we had a couple that were considered good performing schools, and so around 73% of those students were meeting the standard. Now, all of these were before any of them were doing Genius. And so a year later, after a year of doing professional development in Genius and having teachers implement it and so forth, we took a look at their actual writing assessment scores, and here's what happened. As you can see, all of the schools made significant gains, but what's really interesting about this is that the lowest performing schools made the greatest gains, whereas the highest performing schools made the least gains. And in a way, that's kind of predictable, because high performing schools sort of have a ceiling effect. If they're already doing well, there's not that much room for growth, although we did get the going up almost 10 points is significant. Whereas the lowest performing schools by far demonstrated the greatest amount demonstrated the greatest amount of progress. So overall, basically, the results have been fairly consistent with the use of these discipline-specific visual tools. We find that they are far better than traditional instruction in almost anything you look at. So these are pretty powerful devices. Likewise, when we compare these discipline-specific visual tools with the more generic cousins in terms of your basic graphic organizers like basic frames, webs, Venn diagrams, and so forth, we find that the discipline-specific ones are also significantly better than the generic graphic organizers. Likewise, we find that teachers and students really value them highly, and especially students. If you're interested in reading more about this research, there's an article published in the Journal of Education in 2011 by Ellis, Wills, and Deschler. The name of the article is Toward Validation of the Genius Domain-Specific Literacy Model. So if you're interested in learning more about using visual tools for teaching the Common Core standards, I'll be posting a series of other videos on YouTube that you can take a look at if you're interested in professional development or these instructional materials. Please feel free to contact me. My email is edwinellis1@gmail.com, and my phone number is 205-394-5512. Also, if you're interested in participating in some of these research studies, feel free to give me a call.